Okay, so here we go with our last page of IS number 15. This is the big ideas for part 2. So I already wrote out some of these so that I could just talk through them with you. So learning target number 3 is about constructing a confidence interval. So obviously we're going to use the 4-step process. And instead of writing that out all over again, I'm just going to write how this changes from proportions to be for means. So obviously in the state section, instead of stating P as your parameter, you're stating mu, and that it's the true mean, and then fill out your context. And then for the plan step, that changes in that your name of the procedure is a 1 sample T interval for mu. And then the way that you check the normal condition changes. You still have to check the random and 10% condition, and the normal condition, but the way that normal one is the only one that changes. So there are 3 different options. Remember, the population distribution can be approximately normal, or you can have that n is greater than or equal to 30 so that the central limit theorem applies, or your sample distribution can show no strong skew or outliers. If you don't meet at least one of these conditions, then you would say that, I'm going to go ahead and construct this confidence interval, but I cannot be sure that I'm actually whatever your confidence level is, 95% confident that it actually captures the true mean. So we want to make sure those conditions are met. And then the do section changes only in the specific formula. The specific formula now is x bar plus or minus t star, that critical value from the t distribution, times s divided by the square root of n. And then your conclude section should have no changes. You're still using that interpretation sentence for confidence intervals. Okay, so then learning target number 4 is very similar to a learning target from 7-2, section 7-2. This is about determining the sample size when you're given other information, right? Deciding how large of a sample you actually need to have in order to have a certain margin of error with a certain confidence level. So remember the margin of error formula for us now is E is equal to T star times S divided by the square root of N. Okay, so if we rearrange that formula, right, if we multiply by the square root of N on both sides, divide by E on both sides, and then square both sides to get rid of that square root, right, you can follow along in the work if you want to in your textbook, but I think it's more worthwhile to just write what we get from that formula. You would get T star times S now divided by E squared. Okay, so if you're wanting to try to find the sample size you need, you can use this formula for n. And then I also want to note that T star depends on your degrees of freedom, and degrees of freedom is n minus 1. If you don't know n, then you can't find T star. You can make a guess at n if you want to, but what we typically do is just use the conservative choice of using Z star in place of T star if the degrees of freedom are unknown, which, like I said, they normally are. So typically this Z star gets put in the place of T star. Okay, so I think that's about it for the big ideas. Let's actually put this formula into practice in our check your understanding problem. So it's number 1 says, administrators at your school want to estimate how much time students spend on homework on average during a typical week. They want to estimate mu at the 90% confidence level. Okay, that's important, and we're wanting to estimate mu with a margin of error of at most 30 minutes. They're telling us what the margin of error is. I'm already thinking, okay, I'm going to be determining a sample size here because they're telling me the margin of error. And it says, a pilot study indicated that the standard deviation of time spent on homework per week is about 154 minutes. So this pilot study, not sure it's going to be their full study, gave a standard deviation of 154. We're going to need some sort of estimate for S to work into our formula up here. Your book discusses some other options, if you know the standard deviation, which isn't very common, or if you have a pilot study to estimate it with, or they list one other option. I'm not even going to get into it. Our problems will give you a guess for, or an estimate for the standard deviation. Okay, so then it says how many students need to be surveyed? How many students? What is N going to be? All right, so let's go ahead and think about what we need here. I don't know N, so I don't know the degrees of freedom, but I do know my confidence level. So I know that 90% is going to result in an area of tails equal to 0.10, right? 1 minus 0.9 would be 0.1. So I can still use table A3 here. There's this nice function of table A3 that we have not talked about yet. In the very last row, it actually gives z star values. So I'm going to point that out over here on my table. This very last row on degrees of freedom says large. These are actually just z star values. Essentially, if, like we said, our sample size is large enough, the t-distribution is approximation for the normal curve. So whenever my sample is really large, notice it's like larger than 2,000, then I'm using those critical values. So I can follow an area of the tails of 0.10 all the way down to this large row and see 1.645 is the z star value for a 90% confidence interval. Now, in the last set of notes, we talked about how to calculate z-star critical values, and you could have done it using that methodology as well, but this process is just as fast, so I'm going to use this one. Okay, so I know that I want my margin of error to be 30. That's another piece of information. So I have z star, which I'm going to use in place of the t star. I have my margin of error is 30. The other piece of information I need is my sample standard deviation I'm going to use to estimate, and it told me to use 154. Okay, so I just plug that in to the formula. So n is 1.645 for the critical value, times S, which is 154, divided by E, which is 30, and then I'm going to square all of that. Okay, let's plug that into our calculator. So I'm going to use parentheses, 1.645 times 154 divided by 30. End my parentheses and square all of that. Okay, I got 71.3. So obviously, I can't have 0.3 of a student. To ensure I meet the margin of error that I actually want, I always want to round my sample size up, right? Technically, rounding rules would say you would round down to 71, but again, I want to make sure that I have enough people to actually meet this margin of error. So I always round up. I'm going to write that in here in blue to make sure we remember. Always round sample size up. Okay, so that tells us that we are going to need n equal to 72 students for this study to get the margin of error with the confidence level that they want. All right, so that's it for determining sample size. Okay, so number 2 is going to be one more confidence interval, and I think I actually am going to make a second video so I can just break up this page. So I'll do number 2 in the next video.